Properties of skeletal muscles. So the first property we can study is tension. Second is length. Third is types of muscle fibers, types of skeletal muscles. The fourth is motor units, why a muscle heats, in about tetanus, fibrillation, fasciculation. I think that's it. About latent period, contraction period, and relaxation period. Okay. So properties. Contraction is just when the force is generated, the tension changes. This is contraction. Shortening is the length changes. Length and tension relationship in a skeletal muscle is actin myosin interaction. If they are wide apart, then tension is minimum, of course. If actin myosins are overlapping and they have to overlap optimally, the tension is maximum at this point. The length of sarcomere is 2 micron at this time. Actin myosin, what is sarcomere? Sarcomere is this functional unit, one functional unit of a skeletal muscle between two Z lines. What is actin myosin? Actin myosin are these filaments. Cool. So actin myosin overlap is happening, but this is not optimum, so the tension is less than maximum. Cool. What about tension types? What is tension? Tension is the force generated. Cool. So active tension, passive tension, and total tension. Active tension is muscle is stimulated, actin myosin overlap, cross bridge is formed. So if we increase the diameter, if we increase the size, if we increase the length, it leads to more tension, right? More force generated. It leads to action potential, frequency more. So number of motor units recruited. Cool. So more number of motor units recruited. What I'm trying to say is more tension equals to more number of motor units recruited. So what is active tension? Active tension is the tension that is generated when the muscle is stimulated. What about passive tension? What is passive tension? Passive tension is when the muscle is not stimulated. This happens because of titin. So if a structure has titin in it, then we can say it has passive tension. If a structure does not have any titin in it, then it means the structure has no elasticity. What kind of structure doesn't have titin? For example, your uterus. Uterus has no titin. Why? Because it has to accommodate you. If it had titin, it would be elastic in nature. And if it would have been elastic, then it would have made the fetus strangle, right? So that's why uterus has no titin. Cool. What about total tension? Total tension is active tension plus passive tension. That is total tension. Cool. What about length types? Well, first, when actin myosin is overlapping optimally, the tension is max. We call this optimum length, or called resting length. Resting length, all the body muscles are kept at this position. Cool. We understand that this is resting length. Right now, when you're not stretching or contracting your muscles are staying at this optimal length, and this length is best for producing maximum tension. What about equilibrium length? Well, if you cut a muscle from a bone, if you remove a muscle from a bone, we get equilibrium length. What is? We remove a muscle. This muscle was kept in a stretched position. It was kept in an optimal position. We remove this muscle from the bone. This muscle gets back to the equilibrium length of itself, because muscle comes back to its equilibrium because it was kept in a stretched position. It was kept in a resting position, resting length. Cool. What are type of muscles? Well, there are three types of muscle. Type 1A, 1B, 1A, type 1, type 2A, type 2B. Okay. So this is red, this is red, this is white. Why it is red? It is red because its myoglobin is present here. If myoglobin is present, it means it can work on aerobic synthesis of ATP. Cool. If it is white, it means there is no myoglobin, so there is no ATP production from aerobic system. Cool. It is smaller. Smaller means it is very fast. Okay, not nabarot, opposite. Sorry, not fast. It should be small because it's small. Because if a muscle is small, it means less number of motor units. If a muscle is big, more number of motor units. Small, red. Cool. Myoglobin present. It's smaller in diameter. It is slow ATPase because less number of this motor units. Slow ATPase. Fast ATPase because of the size. Fast ATPase because of the size. Myoglobin O2 stores present here. Aerobic pathway. Fatigue resistant. Why fatigue resistant? Because O2 keeps coming in and this has myoglobin in it, and O2 is stored in these myoglobin, and then this O2 can be used for aerobic synthesis, aerobic pathways for ATP synthesis. So that's why it's fatigue resistant. You can use it for a long time. What should we use it? We should use this for sitting. Cool, because we sit on our asses for whole day. So this is small red, slow fatigue resistant. Cool. Motor units, slow fatigue resistant motor units. Cool. What about this 2A? Has a myoglobin, has a large diameter, fast ATPase because bigger in size. It is both anaerobic and aerobic pathways because it's bigger in size. Large, red, fast, fatigue resistant, of course. First, fast fatigue resistant motor units are present. Second to be used, we use it for standing. We are sitting, we standing, and we running. Cool. What about 2B? It's white. It's the myoglobin is absent. It's large in size, fast because of the size. No myoglobin, no O2 stores. ATP anaerobic. So what happens is that when there is no O2 stores, the anaerobic mechanism for ATP synthesis works, and what happens is that glycolysis happens, and then there is lactate formation, and then that's why we have pain and fatigue. So the guys who cannot work out for a long time and they say their muscle hurt, the hurting is because of this kind of muscle. It's large, white, fast, fatigable. Of course, fatigable, that's very important. Fast, fatigable motor units, we use it for running. Last to be used. Small fibers are recruited first. Okay, because they are easy to be recruited and they are they have aerobic metabolism. Large later, we call this size principle. Cool. Okay. What is motor units? A single alpha motor unit innervates how many muscles? It depends upon how many muscle fiber. It depends upon the function. If the function is very precise, okay, fine and precise, then one motor unit may innervate 3 to 6 muscles. But if the function is coarse movement, a very big movement, then one motor unit can innervate around 600 muscle fibers as well. And this is not tightly regulated, because to be tightly regulated, we need to innervate 3 to 6 muscle fibers per motor unit. But here it's coarse movement, so 600 muscle fibers. Extraocular movement, the movement of an eyeball, one motor unit, 3 to 6 muscle fibers. Cool. Why do muscle heat? Well, there are two types of heat. Resting heat. This is basal metabolic reaction, BMR. If your BMR is high, your resting heat will be high. You will not be able to gain a lot of weight. What about contraction heat? This is the heat generated when your muscle contract, when this cross bridge formation is happening on your actin and myosin. Before interaction of actin and myosin, activation heat is needed to activate them, of course. Soon after activation, proteins undergo shortening. Shortening means contraction. So shortening heat is needed. Cool. Finally, at the rest, relaxation heat is there, and muscle now recovers, and we call this recovery heat. So we have 4 types of heat. Recovery heat is the final heat. Relaxation is relaxation. Activation is needed to activate actin myosin, and shortening heat is the shortening heat that is generated after the proteins undergo shortening, that is contraction. If you give one simple stimulus, you get simple muscle twitch. Cool. The components are, what are components for muscle twitch? What is muscle twitch? It is a movement. Okay, so you give one simple stimulus, you get simple twitch, simple muscle twitch. In this muscle twitch, so this is one muscle twitch, the movement of muscle. We can see this is the contraction period, this is the relaxation period, and this is the latent period. What is latent period? Latent period is the period between two consecutive full cycle of contraction. We give stimulus here, the contraction starts here, right? So this period between the stimulus and the contraction is called latent, and this period from contraction to the peak of contraction, it's called contraction period. From the peak of contraction to relaxation, it's called relaxation period. Latent, contraction period, from end of the latent to peak of contraction, relaxation is relaxation. What about incomplete tetanus? What is incomplete tetanus? The relaxation period smalls, right? The relaxation period is this small, and we increase the number of stimulus. So the contraction are increasing, but the relaxation are decreasing. So we call this incomplete tetanus. What is complete tetanus? The number of stimulus are increased. There is no relaxation because accumulation of calcium ions. Why? Because of a toxin called tetanospasmin. It stimulates the muscle at a frequency, and we call that frequency tetanizing frequency. So tetanizing frequency equals to 1 upon contraction period. Contraction period. So tetanizing frequency equals to 1 upon contraction period. It's very important. Why it's important? Because we can solve a lot of questions. For example, this is one. This is for just say this is one muscle twitch. Again, this is the latent. This is the contraction. This is the relaxation. I know tetanizing frequency equals to 1 upon contraction period. This is my contraction period. This is my contraction period. This is my contraction period. I see 1, 2, 3, 4, 5, 6, 7, 8, almost 8, and usually one of this wave equals to 10 millisecond. So 8, 1 upon 80 equals to 17.3 second. So tetanizing frequency for this is 17.3 second. Okay. Sustained contraction. Because why it's sustained? Because there is only contraction, no relaxation. What about fibrillation? Fibrillation, there is problem. The problem is focal, small. There is twitch of single muscle fiber, alpha motor neuron, or its axon has this problem. Okay. What is fasciculation? Fasciculation is a group of muscle fiber messed up, multiple motor unit messed up. So this was simply properties of skeletal muscle. Not a big topic, but simple topic.